Hi, this lesson is on equilateral triangles. So today's objective is to be able to use the property of equilateral triangles to solve for a side, angle measure, or variable. Let's talk about equilateral triangles. So equilateral means equal, and then lateral means sides. So in other words, this is a triangle with three congruent sides. So we can mark that by putting the little hash marks, little tick marks on each of those sides. But an equilateral triangle is also what's considered equiangular. And angular means angles. So not only does an equilateral triangle have equal side lengths, it also has equal angle measures. So three congruent angles. In an equilateral triangle, it could be a small little triangle or it could be a really big triangle. But the interesting thing about these is it will always have an angle measure of 60 degrees. And that is because if we take this equilateral triangle, and let's say angle A is x, because all three of these angles are the same, that means all three of these are x. We know that we can add the angles of a triangle, add them all up, and it's going to equal 180 degrees. That's the triangle sum theorem. So combine my like terms and divide by 3, and we can see that every angle of this triangle is going to be 60 degrees. So let's see how this works for us when we're solving problems in geometry. Here we have a problem where it says to solve for the variable and find the length of each side. This is an equilateral triangle, which means all three of these sides are congruent. So I'll mark that in here. And so to solve for x, you just need to pick two expressions and set them equal. It does not matter which expressions you pick, just pick any two. So I am going to use rs, the x plus 9, and set that equal to rt, 3x minus 9. So I'll move the x over. And I'm just solving for x. And we find that 9 equals x. So we solved for a variable, and now we need to find the length of each side. To find the length, just go ahead and plug in the value of x. So if x is 9, 9 plus 9, 18. St, 2 times 9, 18. And then rt, 3 times 9 minus 9. This is 27 minus 9, which is 18. All three of these sides agree that it is an equilateral. All three sides are equal and the length of 18. All right, what if I don't have a diagram? So this problem says that triangle FGH is equilateral. So I'm going to start off with drawing my triangle first. So there's FGH, and it says one of the angles is 4x minus 6. Solve for x. Now it's not telling me any more information. So we could solve this in a few different ways, and I'll show you two ways. One way is, if you remember back at the beginning when we talked about equilateral triangles, we said equilateral triangles are also equiangular, which meant that all the angles were congruent, and we did the math to show that all angles equal 60 degrees. So we could say 4x minus 6 equals 60. And we can solve for x. So x would equal 16.5. That would be one way if we remember equilateral has angle measures of 60 degrees. The other way we could do this is we could say, well, I don't remember it's 60 degrees, but I know that all the angles are congruent, so I could add up 4x minus 6, and I could do that 3 times to represent each one of my angles. And then say that equals 180. Because g would be 4x minus 6, and h would also be 4x minus 6. And then we can go through and solve this. So combine my like terms. Add 18. And then divide by 12. X equals 16.5 still. Okay. So you can go about it either way. It just depends on which properties you remember about your equilateral triangles. All right, here's a different type of problem. Here it tells me the perimeter of an equilateral triangle is 36. So draw the triangle. And my perimeter is 36 centimeters. Perimeter means add up all the different sides. So I'm going to add up this side, and that side to equal 36. And this tells me that the value of the measure of one of the sides is 5a plus 7. So what I'm going to do is I'm going to label 5a plus 7. This is equilateral, so all 3 sides are 5a plus 7. Now we can use that definition of perimeter. Add up all the sides to equal 36. One side, my second side, and my third side. Combine like terms. And solve for a. So here a would equal 1. Now there is another way you could do this problem. If I know my perimeter is 36, I know that triangles have 3 sides, and since all 3 sides have to be the same, I could say 36 divided by 3 equals 12 centimeters. And that would be the length of each individual side. So 5a plus 7 would equal 12. And you could solve. And you still find that a equals 1. So there's 2 ways to do this. Just like with the last problem on angles, we can solve it with 2 different methods, adding all of it up or looking at it as one individual piece. You just decide which one works best for you. So on this example here, I want you to get started with it. Watch out because it gives us 2 different variables. I have a y variable and a w variable. So to start this problem, I want you to start off with finding w, because w has 2 variables. There's 2 expressions with the variable w, so you're going to start off with finding w and then find y. So go ahead, hit pause, try this problem out, and then we'll come back and finish it together. Okay, welcome back. Hopefully you got a good start on this, so let's talk about the first step here. That was to find w. On an equilateral triangle, all of the sides are congruent, which means I can set the 2 expressions with the w variable equal to each other. 12w minus 35 equals 3w plus 19. I'm going to solve for W. So W equals 6. To solve for Y, we first need to plug in our W. 3 times 6 plus 19. So we find that each of these sides are the length of 37. And since it's equilateral, remember, all my side lengths equal 37. So this one also equals 37. And now I can solve for Y. So set my Y expression equal to 37, the length of each side. And now we find Y equals -7. So this was a 3-stepper. Then we plug in W, and then we found Y. All right, our very last problem here is determining what type of triangle we have here. Remember, equilateral has 3 congruent sides, isosceles has 2, and a scalene has 0 congruent sides. So we need to first plot our points. And I'll draw the triangle in. Once my points are plotted and my triangle is drawn, I can go ahead and start finding side lengths. I'm going to start with AB. So a side length is just the Pythagorean theorem. That distance formula is really the Pythagorean theorem. So I'm going to draw my right triangles in by following the coordinate plane and then count those boxes. Those measures become my A and B in my Pythagorean theorem. Three squared is 9, 2 squared is 4, 13 equals AB squared. And now we'll take the square root because we want to undo that square. So the square root of 13 is the length of AB. Do the next side now. So BC follows my coordinate plane. So all I need to do is count the boxes. 4. And my last segment is AC. So AC, we need to draw our right triangle in by following those coordinate plane lines, count those boxes, and then use those values to plug into the Pythagorean theorem. So 3 squared plus 2 squared equals AC squared. And that's 9 and 4 when you square those values. So 13 equals AC squared. We need to undo this square, so we're going to take the square root and we find that AC is the square root of 13. Now we have all 3 of our side lengths listed. We can determine isosceles, equilateral, or scalene. I can see I have two sides that are the same length. So two congruent side lengths means this is isosceles. All right, so that's the last example for today's lesson. Let's just recap and summarize a few quick points. Remember, in an equilateral triangle, every angle equals 60 degrees. So here I have an equilateral. All three of these equal 60. And also remember, all three sides are congruent. And that's all you need to know today for equilateral triangles.